Hello, students. Let's do the third activity in Unit 8.4.12. So the first thing I want you to do is get out your math notebook and put something on there that tells you what you're doing. The unit is 8.4.12. Put that at the top of your paper, and the name is Stack of Cups. Remember that we are learning system of equations. System of equations is two equations that represent a situation together. Okay? Now read the problem with me. A stack of n small cups has a height h in centimeters of height equals 1.5n plus 6. And that's said for a stack of small cups. Then it says a stack of large cups. A stack of n large cups has a height h in centimeters of h equals 1.5n plus 9. So they're giving you the two equations. What they didn't give you was the table on the side that I drew that I think makes the problem more understandable. And then I gave you these pictures to help you imagine a small stack of cups and larger cups. And they're stacked like this. So if you only have one cup, you have a certain height, h. But when you start stacking the cups, then the height goes up little by little by little. There, so you can see the height is increasing. Okay, erase that. Question number 1 says, graph the equations for each cup on the same set of axes. Make sure to label the axis and decide on appropriate scale. Okay, well, I'm pretty good at this, to be honest. So I already made some labels right down here. And I decided that I will put the height of the stack on the y-axis. So I'm going to move my label right here. Yeah, right about there. And the number of cups is the label on the x-axis. You need to do that yourself. And it says to decide on a scale, an appropriate scale. Well, before I do that, I'm going to look at this data table and fill it out. I already put in n. N is the number of cups. So I put in 1 cup, 2 cups, 4 cups, 6, 10, 20. You can put in whatever you want, but those are the numbers I chose. And then in green, it says h small. That's the height of these small cups. And then in purple, it says h large, which is the height of the red cups. I should have made it red, whatever. So let's go ahead and fill out that table. Let me get my green pen ready. Okay, if you have 1 cup, and remember, I'm looking at this equation over here, you write that down in your notes, okay? You should do this in your notes. Don't just listen to me, make sure you understand it. If you have 1 cup, then n equals 1, and you have 1.5 plus 6. So that's going to be 1 cup stacked on top. Okay, got it? 1 cup stacked on top. N equals the cups stacked on top. So 1.5 plus 6. That means the first cup is 6, but we have 1 stacked on top. So 1.5 plus 6 is 7.5. That's for the small cup. Now let's keep going. If you have 2 cups, then n equals 2. So 1.5 times 2 is 3. 3 plus 6 is 9. If you have 4 cups, then 1.5, look here, 1.5 times 4 equals 6, and then plus 6 equals 12. Keep going. Now, what if you have n equals 6? That's 6 cups stacked on top. If n equals 6, then 1.5 times 6 is 9, right? Yeah, 9. 1.5 times 6 equals 9. plus 6 more equals 15. You can check my math with a calculator. In fact, you better check my math with a calculator. Don't trust me. Now, if n equals 10, then that's 1.5 times 10, that's 15, plus 6 is 21. What if n equals 20 cups stacked on top? So then 1.5 times 20 is 30. 30 plus 6 is 36. Try doing the math in your head and then check it with a calculator. But if you're not so good at math in your head, no problem. You should be writing it in your math notebook. Okay, so I can go ahead and plot these points on the graph. Before I do, though, I'm going to fill out the table with the large cups. Filling out the table reminds you how to use these equations. Okay, so when you have one large cup, and let me highlight or show you where I'm looking. Now I'm looking at the equation for the large cups. If you have one large cup on top, one stacked on top means n equals 1. That's 9 plus 1.5, 10.5. If you have two cups stacked on top, that's going to be 1.5 times 2, which equals 3. 3 plus 9 is 12. If you have 4 cups stacked on top, then 1.5 times 4 is 6. So 6 plus 9 is 15. Do you see the pattern? It's always 3 centimeters more than the small cups. Look at the next one. When n equals 6, then 1.5 times 6 is 9. 9 plus 9 is 18. Look, it's 3 centimeters greater than the stack of small cups. It's always 3 centimeters greater. 9 plus 3 is 12. 12 plus 15. 12 plus 3 is 15. 15 plus 3 is 18. So that's going to keep going. Look at the pattern. When n equals 10, it's 1.5 times 10 plus 9. So that's 15 plus 9. That's going to be 24. And the last answer, you can check my math and you'll see that you get 39. Okay, you can plot the points on the graph, but actually you didn't have to. You didn't even have to make that table to do this. I just want to show you how these equations work in case you're still not good at that. Now, if you are good at using equations, then you just take one look at this and you see that that's the y-intercept right there. Plus 9 is the y-intercept, and the slope of the line is 1.5. So we need to label the axes. Let's go ahead and do that. I'm going to put the scale. I said label the axes. What I meant to say is scale. Sorry, excuse me. Let's put the scale on here. So down here at this point, that is height equals 0 and number of cups equals 0. That's the origin. And I think it's best to use a scale of 3. So every line equals 3. And I decided that. You can do what you want. I decided that's best for me. So let me go ahead and put my scale on. I'm counting by 3s. You can count however you want. If you have a better idea, then you do it your way. But make sure that you have a reason for the scale that you choose. Maybe mine's not the best. Wait and see. The top is 30. Okay, now along, you know what? My labels disappeared. Where did they go? My height is here, but somehow I lost my number of cups on the bottom. I don't know what happened. Just remember that it was there. In fact, I'll write it again. Okay, so on the bottom was n equals number of cups. So this tool that I use to paint on the screen does not work properly. Sometimes I lose stuff. Number of cups. Okay, now for my scale on the number of cups, I decided to count by ones. So 0, 1, I'm just going to go ahead and do that. 2, 3, 4, 5, 6, keep on going. You can do something different if you want to. You do what you want to do. Maybe I should have counted by twos. I don't know. Anyway, so if you're good with equations, you can just look at the first equation and you'd be like, okay, the y-intercept is positive 9. And that is for the large cups. The large cups is right here in blue. So let me do the large cups first. The y-intercept is positive 9. I'll try to make a little dot right there. And the slope is 1.5. That means every 1 cup goes over 1.5. So go over 1 cup and you go up 1.5. And then go over 1 cup and you go up 1.5. And then go over 1 cup and you go up 1.5, which is half a block according to the scale that I chose. Go over 1 cup and you go up 1.5. Let's check my number. So for 4 cups in my table, I see that 4 cups has a height of 15. Yes, it does. So I'm correct. I can double check with the table. I don't need to keep going. Now that I have 2 points on the line, I can use that to draw a straight line and extend it. So make sure it's accurate. I know it's accurate because every cup I go up 1.5. That means every 2 cups I go up 3 centimeters. So look at my slope triangle. Every 2 cups I go up 3 triangles. Every 3 cups I go up 3 triangles. Every 3 cups I go up 3 triangles. 3 centimeters. I should stop making videos after 10 p.m. Whatever. That's how I graphed the large cups. It's in blue. Now I'm going to change to green and I'm going to graph the small stack of cups. So the small size cups has a y-intercept of +6. I'm going to use the same method and then I can just check it with the numbers in my table. Okay, so starting at +6, that means the y-intercept is 6. And every cup goes up half an inch. So 2 cups goes up 3, not inches, centimeters. Every 2 cups then goes up 3 centimeters. I'm looking at the slope right here. Okay, so 1 cup goes up 3. I just can't talk, but I really hope you know what you're doing. 1 cup, if you go over 1 cup, you go up 1.5 centimeters. Over 1 cup, up 1.5 centimeters. Believe it or not, I really practiced this lesson. I just can't talk after 10 p.m. So my slope line is looking something like this. Here are my slope triangles. And then when I get to 4 cups, I should be at 12 centimeters in height, which is exactly what I have in my data table. Now, I don't need to keep going. I'll just get a straight edge and draw a straight line. And it must show the correct slope. The slope is every 2 cups, there is 3 centimeters in additional height. The height goes up 3 centimeters every 2 cups. Okay, there's my graph. You could have done it in half the time if you just looked at the equations and then plotted out the slope. But I showed you the data table here to prove it to you how these equations work and to prove that I have the correct slope. Now let's answer number 2. Question number 2 says, for what number of cups will the 2 stacks have the same height? Never. They will never have the same height. Look at the graphs. They are both increasing at the same rate. Even though 1 cup is larger, it increases at the same rate as the stack of small cups. So the height of the small cups will never equal the height of the large cups, and the height of the large cups will never equal the height of the small cups. If you keep stacking 1 cup on top of the other, the heights increase by the same increment. They increase at the same rate. Those lines on the graph, they are parallel. They will never intersect. So there's never going to be a time when the same number of cups gives the same height. That will never happen. You can see by looking at the parallel lines on the graph, they don't intersect. So there is no solution to this system of equations. Let me say that again. There is no solution. The lines do not intersect. Take a look at this next slide. What is a system of equations? I've said it already a few times in class, but now let's make sure you've got it down. So get your pencil ready and write this down in your math notebook. What is a system of equations? It is, oops, and my text tool stopped. Let me try again. It is more than one equation for the same situation. There we go. More than one equation for the same situation. Okay, we've got a situation and there are two equations or three or four that describe the situation. Number two, what does the solution to a system of equations represent? That is the solution to the system of equation represents when both equations have the same ordered pair. There's an ordered pair that makes both equations true. It's when the value of each equation, when the value of the equations are equal. So looking at the graph, when those two lines intersect, that is the solution to the system of equations. That is when both equations have the same value. Go ahead and write that down in your notes, when both equations have the same value. Number three, where do you see the solution to a system of equations on a graph? Oops, I already said that answer a few times. It is at the intersection of the lines, because at that intersection, they both have the same x and y value. Okay, now that was excellent, guys. Here were our learning targets, and I'd like to know how well you did on these in this assignment. The learning targets were, I can explain the solution to a system of equations in a real-world context. So you did that in 3 different cases. You had the first was milkshakes, I remember now. When they were drinking milkshakes, you had to find the time when Lynn and Diego finished their milkshakes, and when you graphed those lines, you could see a moment when Lynn and Diego had the same amount of milkshake in their cup at the same time. And in the second example, in the second activity, the passing on the trail, you saw when Jada and Han were hiking in opposite directions when they passed. At that passing point, they were the same distance from the parking lot at the same time. That's when they passed each other. And then for the stack of cups, well, you saw that there was no solution to that system. There was no stack that had the same number of cups and the same height. That never happened. Okay, next learning target. I can explain what a system of equations is. So how do you feel about that? Can you explain that? We answered that on the previous question. Try to remember what you learned. And the last learning target. I can make graphs to find an ordered pair that 2 real-world situations have in common. Listen again. I can make graphs to find the ordered pair that have 2 real-world situations in common. 2 answers. So that's where the lines intersect. And you did that. You graphed the milkshake problem. You graphed passing on the trail problem. And then you graphed the stack of cups problem. Yeah, you made those graphs. And then you looked for an ordered pair where the lines intersect, if they had an intersection. Go ahead and rate yourself on these learning goals. Circle how you feel about each target. Then, dun, 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 there is a bonus question. I don't want to drag out this video any longer, and this is bonus, so I expect you to do your best and show what you learned, okay? Don't forget to label your graph and have accurate lines. See ya.